Hi, this is the third video for a geometric series, In the last video, I showed you how to prove and use the sum of a series formula for a geometric series. In this one, we're going to look at how to work out the sum to infinity of a convergent geometric series. So, first of all, what do I mean by a convergent geometric series? Well, if you think of this series, 12, 6, 3, 1.5, 0.75 and so on, as each term is halved in this case, these are just going to get smaller and smaller and smaller and smaller, okay? And they're going to converge to 0. So the terms are getting smaller and smaller and closer and closer and closer to, in this case, 0. Now we can work out the sum of infinitely many terms of that series. Now it seems a bit bonkers that you can work out the sum of infinitely many terms, but we can as long as it is convergent. And just to illustrate, I've just got a circle here. Okay, so that circle is representing one whole one. If I split it in half, then that's a half plus a half. So those two still add up to a whole one. Now I could split that again, and that is now a half plus a quarter plus a quarter. That's still a whole one. But I could split that again. That's now a half plus an eighth plus an eighth. But I could split that again. That's a half plus a quarter plus an eighth plus a 16th plus a 16th. That's still a whole one. I could go again. That's a half plus a quarter plus an eighth plus a 16th plus a 32th plus a 32th. I could go again. Should be another one. There it is. That's a 64th plus a 64th. But the idea is that I could just keep going on and on. So you'd have, instead of that, you'd have a 128th, and then you could have 1 256th, and 1 512th, and 1 1024th. And as these terms are converging, I could just keep splitting and splitting and splitting. But ultimately, because I could just keep splitting infinitely many times, the whole thing is still going to be 1. So that's what I mean by the sum of a convergent series, the sum to infinity. It's still, we still can work out the sum of those terms. So we look at this series here, 4 plus 2 plus 1 plus a half plus a, you can see that this is a convergent series because this is just getting smaller and smaller and smaller. The series converges towards 0 as n tends to infinity. So as n gets bigger and bigger and bigger, the position number gets bigger and bigger and bigger, then the series is converging towards 0. In this case, well, we can see that the sum of this series, hopefully you can see, is 8, because those 3 add up to 7, and then I've just shown you from my previous diagram that a half downwards, this is going to add up to 1. So all of that is 1 plus those 7 is 8. So that series to infinity adds up to 8. Now, this is only, remember, for a convergent series. So the question is, what value of r will determine whether or not the series is convergent? Well, in this case, r is a half. Well, r doesn't have to be a half. what does R have to be? Well, it just has to be small. What do I mean by small? Between -1 and 1. Okay, it can be negative. It can converge. So it could start off at 4, -2, 1, -0.5, positive 0.25, -0.125. So that this is where R is -0.5. Okay, you can see, yes, it's moving backwards and forwards between positive and negative, but actually it's getting closer and closer and closer to 0. So if you were to sort of graph that, it would be like that, jumping and jumping and jumping and jumping either side of positive and negative, but it would eventually get to 0. So this is an example also of a convergent series. So R has to be between -1 and 1. R is small. So how is that going to impact the sum of the series formula? Well, let's have a look at the sum of the series formula. Here it is. This is how it stands for any series. So what we're saying is that R is between -1 and 1, and N is tending to infinity. Well, if this is small, less than 1 or greater than -1, so 0 point something, and you apply a big power to it, this bit here is going to tend to 0. So if you've got a small number with an ever-increasing power, this is just going to get smaller and smaller and smaller and smaller. So actually that is going to tend to 0 as n tends to infinity. So what we're left with is just a over 1 minus r. And that is denoted by s with a little infinity sign. So the sum to infinity is a over 1 minus r. Okay, and you get that in the formula booklet as it is. So it's dead easy. So in the terms of the previous one, 4, 2, 1, a half, a quarter, that was on the previous slide, that added up to 8. A was 4, R was a half, so the sum to infinity is A, which is 4 over 1 minus a half. 4 over a half, 4 divided by a half, which is 8. Okay, so that is the sum to infinity for a convergent series. It won't work unless R is between -1 and 1. Okay, so now we need to be able to work out the sum for a given series, and also you need to be able to problem solve using that fact. So we're just going to look at a couple of questions, and then we're actually going to look at a review of sigma notation for geometric series. So find the sum to infinity of the series. Okay, so A is 40, R is 10 divided by 40, which is a quarter. So the sum to infinity is A over 1 minus R, 40 over 1 minus a quarter. 40 divided by 3/4, which is the same as 40 times by 4/3. So remember, if you divide it by a fraction, you multiply by the reciprocal, so it's going to be 160 over 3. And that's that. Okay, so that's just using the formula. Write down what A is, write down what R is, and sum it in. Find the common ratio of a geometric series with first term 10 and a sum to infinity of 30. Okay, so this one, we know A is 10. We know the sum to infinity is 30. What we don't know is what R is. Okay, but we do have a formula. A over 1 minus R. So if we just put in what we know that's 30. We know that that's 10. We don't know what that is. So we just need to solve that equation now. This is on the bottom. So if we times by 1 minus R to get it off the bottom, 30 lots of 1 minus R equals 10. Expand the brackets and then just rearrange. Minus 30R equals minus 20, which means R must be 2/3. Minus 20 over minus 30, which is positive 2/3. Okay, slightly harder. The sum to 4 terms of a geometric series is 15, and the sum to infinity is 16. Find the possible values of R. The sum of 4 terms of a geometric series is 15. So the sum of 4 terms is 15. The sum to infinity is 16. Now don't forget there are very similarities between these two formulae. Sum of 4 terms, A 1 minus R to the 4 over 1 minus R is 15. So really that's all we know about that one. Sum to infinity, 16, is A over 1 minus R. Okay, so essentially we've got two equations. We've got simultaneous equations with two unknowns. Now we could make A the subject here, I suppose, and substitute it in. Alternatively, so it might be slightly easier, is that there is that. So this is 16. So rather than substituting in for A, I'm going to substitute in for A over 1 minus R. So actually we've got that. I'm going to divide by 16. Or shall I expand out? I'll expand out. 16 minus 16R to the 4. Take away 16. So that's going to be minus 1. Minus 1 equals minus 16R to the 4. Divide by minus 16. R to the 4 equals 1/16. And then take the fourth root. So we want the fourth root. R is the fourth root of a 16th, which is a half. Fourth root of 1 is 1. Fourth root of 16 is 2. And that's R. Okay, what else could it be? Well, we've got the fourth root. It's just like when you've got a square root, because it says possible values. Okay, so just like if you're doing x squared, you would have plus or minus. If you're doing x to the power 4, you would have plus or minus. So actually we could have both positive or negative. And that's that. Okay, so you might have to combine formulae. There would have been other ways of doing it. That's just the easiest way to do. Okay, so just spotting that. Okay, and then the last thing is sigma notation. So I'll just remind you what sigma notation is. Sigma notation means sum of. You've got a starting value and you've got an end value. This is in terms of position. So if you have got something like that and you're doing 2 times 3 to the r, let's say, then the first term would be 2 times 3 to the 1. The second term would be 2 times 3 squared, so that's 18. The third term will be 2 times 3 cubed, which is 3 cubed, which is 54. The fourth term is 2 times 3 to the power 4, which is 2 lots of 81, 162. And then the fifth term is 2 times 3 to the power 5, which is something. Two lots of 243, so 486. Okay, so in this case, so the sigma means sum of, so you're adding up, that's where r equals 1, that's where r equals 2, up to where r equals 5. So first position, last position, and that's the rule to generate. Okay, right, so what you need to do, and we will mark these in the tutorial, is write down, I would say, the first 3 terms of each one. Okay, some of them, as you can see, have got an infinity. That's because the common ratio is going to be between -1 and 1. Okay, so write down the first 3 terms. All of them are geometric series. So based on the first 3 terms, write down what A is, write down what R is, and then work out the sum. Okay, that's the sum to infinity. That's the sum to infinity. That's the sum of the first 20 terms. These two, you're just going to have a little think about it. How you're going to do it. Okay, and we will discuss it in the tutorial and mark it. And then we're done for this video, so you should be able to practice exercise 3E, questions 1 to 9.